Hi everyone, we will be waiting 2 to 3 minutes before we get started, just to accommodate for the rest of the attendees who are in the middle of connecting. So, welcome everyone. I'm Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we start. So, this webinar is being recorded and will be shared publicly. The recording will be posted on our community at aka.ms/securitywebinar and is now structured in the product group. During the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Questions you post will be made publicly available, and if you prefer, you can ask your question anonymously by checking the box right below where you entered. As you can imagine, we can get many questions sometimes during this webinar, and we are doing our best to respond to all of them in real time. But if the answer was not provided, or if you have additional questions afterwards, please don't hesitate to ask them on the Microsoft Threat Protection Forum at aka.ms/mtptc. If you're listening to this after the fact as a recording, you can also use this place to ask questions. We love to hear your feedback on how we can improve these webinars, so please do that at aka.ms/securityWebinarFeedback. This is important so we can deliver the content you need. If you haven't already, please join our community at aka.ms/securitycommunity. So that's always the best to ensure you don't miss any future webinars or major announcements. In our community, you can speak directly to the engineering teams that are building our security products. And for Microsoft Threat Protection, you can do that at, again, aka.ms/mtptc. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So please join us. So today is the last episode of Tracking the Adversary. Michael Malone, Principal Program Manager, delivered already 3 demo-only episodes. And today he's actually joined by Tali Ash, and they will conclude the series together. And with that, no further ado, Tali, handing over to you and let's hunt.
Thank you, Heike. Let's move to advanced hunting. So today we will hunt together, and Michael will walk us through the ABCs of security. But before we're starting to hunt, most of the time you will ask yourself, what is the data that is available? What events, what are the tables, what are the schemas? So you will better understand the data you have, and then you will know how you can hunt for what you are looking for. You can easily understand the schema and the data available in advanced hunting using the schema reference. This is documentation inside the portal, which gives you information about the different tables and the data available in each table. You can see here the full list of tables. You can also search for a specific table. So if we're searching for alert, we got 2 tables. Let's click on alert info to better understand what we expect to see in the table. So as you can see, we have the description that describe what is the table. We can see it contains information on alerts coming from the different Microsoft security products. Under columns, you can see all the columns of the table. For each column, you have a description. This information is actually identical to what you have here when you expand alert info. You can see the description of columns also here when you hover a column. The most interesting part is the sample queries. For each table, we provide you examples of queries that you can use to start understanding that table. Maybe it's the first time you're using it, you would like to get familiar with it and play with it. You can easily click on a sample query. The query will get added to the editor, and then you can run it. Alerts by severity, you can see that we count distinctly the alert by the unique identifier of the alert ID, and then we get a result of the severity. If you would like to see the amount of alerts we have based on the MITRE attack different technique, again, I just clicked on the sample query, it is being added, I can run it, and I will get the information. If you're looking for a specific information on a specific table, you can get to the reference of the table also directly from the schema. So for example, let's look for device network events. You're wondering what is this table, you would like to know more about it, you can click on the 3 dots, view reference, and the documentation of the specific table will get opened. Again, you can see the description, the columns, and also action types. As you can see here under the schema, we have 2 main types of tables. Most of the tables ends with events. This type of tables contains information about events or activities that were monitored by one of our sensors, whether it is coming from endpoints, from emails, from cloud apps and identities. And the second type of tables we have ends with info, the suffix info. In these tables, you will find a state of a specific entity. So for example, in identity info table, you will have a state of the entity that we are getting from Azure AD. So most of the tables that represent events will have action types. The action types are the different event types we have in the table. You can see a list of the different action types and description for each event. If you would like to, again, to start play with the table and better understand what is connection request, you can click on it, and the filter for the events types of connection request will be added. I will just limit the result set. Then you can query it, and you will get a sample of the data, and you can get better understanding of what is a connection request. So this is a way to start exploring the data is available in advanced hunting. And now that we know how we can find what we're looking for, we can start hunt. So Michael, the stage is yours.
Thank you very much. So I'm going to go ahead and switch windows over to my advanced hunting windows. So today we're going to kind of culminate all the content we had over the previous 3 episodes. So if you're just tuning into this one for the first time, if you see some things that might be kind of foreign, or some operators or that might be maybe you haven't seen or used before, definitely check out the first 3 episodes we have because we actually walked through this through 4 different episodes. The first 3 is really building up the knowledge to come at this 4th one. But to get started, I actually want to start off by talking about a generic concept that's, to be honest, it's not even directly an MTP topic. It's what I like to refer to as the ABCs of security. So I use this topic for training a lot of our Microsoft DART members, our Targeted Attack Incident Response team. I've also used this a lot to train our compromise recovery team. But the basis of it is when you're doing your analysis, you can break down the things you need to look into most of the time in 4 basic categories. So you've got authentication, you've got backdoors, you've got communication, and you have data. And we'll be applying these concepts during today's hunt. But to get things started, so authentication. So when you're from an authentication perspective, the question you should be asking yourself is, how did the attacker establish identity to the system? What identities do we consider compromised, and what are our administrative identities? So for example, if we see a piece of malware that's running on the machine, you may want to go back in time and look into what identity led to that malware appearing. It typically doesn't just magically appear unless you're dealing with an exploit. Usually it's going to be a user clicking on it, maybe an email phishing attachment, or maybe there's something publicly exposed and an attacker was able to break a weak authentication mechanism and copy the file there and install it. Or sometimes there's going to be an exploit possibility as well. But the authentication aspect is extremely important from a tracking perspective as well. So if you know that an attacker has a credential during an incident, this needs to become part of the things you look into from a recovery perspective. So as you're cleaning things up, so MTP is going to give you a bunch of good intelligence, and we actually have the ability in certain cases to identify if there is if we believe an identity to be compromised, but definitely track any identities you come along during your investigation as being potentially compromised or also administrative. So, and this is important because administrative essentially means it can circumvent normal security processes. So your administrative identities are going to be the ones you want to ideally reset as well if there's any potential that they have been exposed or compromised during the attack. Second one is going to be backdoors. Now, I use the term backdoors because it fits in the ABC construct, but essentially it's how is the attacker controlling the system. So a backdoor can be a legitimate publicly exposed interface. So for example, if you have a vulnerability on a public facing website, the backdoor could be the ability to trick the web application into uploading an arbitrary file into a web published directory. That would be how a web shell would come about. It could also be RDP or SSH that's exposed to the internet. And basically, there needs to be some mechanism for the attacker to control it. Now, in most traditional APT style attacks, or like if you have targeted ransomware attacks, a lot of times the backdoor is a piece of malware that's installed by the attacker. So this would be like a Trojan malware. You might see Trojan dropper, Trojan downloader, but those are what we like to refer to collectively as a reverse shell. Essentially, it's a piece of software that installs itself on the machine, connects off to an attacker control channel, a C2 or communication channel, if you will, where the attacker can feed up commands, and then the malware will grab the commands from the command and control channel and run them on the endpoint. A lot of times these are used over SSL. More advanced ones we've seen over DNS. There's other obscure ways to communicate, but basically the goal from a backdoor perspective is what mechanism did the attacker use to control the endpoint during that incident? Now, once you have that, there's a couple of different situations you can track down. So for example, you have a bad file. So for example, a piece of malware is typically able to be uniquely identified by its hash. There's also the possibility that you have something like a PowerShell script where the PowerShell executable itself is benign, but the launch string is being paired with, it could be the actual attack, maybe the downloader, if you will, that actually says go off to this URL or this IP address and run the command on this box. So it's important to delineate between the two, because if it's the PowerShell command line side of the house, you won't be tracking PowerShell. You'll be tracking attributes of the launch string for PowerShell. Remember our device process events table. The other side is if it's a piece of malware, we can track it typically by antivirus detection, so what did Defender endpoint protection call it, or based on its file hash. There's a bunch of advanced topics in this area around polymorphism and such, but from the basic perspective, the question from a backdoor perspective is how did the attacker control the endpoint during the attack? The third one is communication. So communication, and I'm going to go through this line here. Communication is essentially what's the communication path between the attacker and the system itself. So this can be an inbound connection to a publicly exposed service of some sort. This can be a reverse shell, as we talked about, so the communication back to a known command and control channel. This could also, in some cases, in the case of phishing, technically what you're doing is your control channel might be an email that's sent to a user. That's your communication path. And then the user performs an action on their behalf. So it could be almost done by proxy, if you will. There's also, so we're not going to go too much into it, but so the data aspect of it is essentially understanding which sensitive information was either tampered with from an integrity perspective, destroyed or made unusable from an availability or utility perspective, or stolen from a confidentiality perspective. So I use the ABCs whenever I get into an incident as a framework for the things that I should be looking for at each stage of the attack. So when you have your alerts or you have your incidents in MTP, dig into them and see if you can figure out the ABCs of the incident before moving on. That's a kind of a nice little guideline you can use during your hunt. So Tali already talked a bit about alert info. So if you remember, alert info is essentially the generic alert details that we have in MTP, and then you have alert evidence, which is, if you remember from our last episode, is the specific entities that are related to the alert itself. So the user accounts, the mailboxes, if there's a file, etc. So let's start using these concepts and look into our incident. So we're going to start out, I'm going to use the alert evidence table, and I'm going to find user entities where the account object ID is populated, because we're going to use, if you remember, account object ID is the most authoritative way to correlate your users. You can do it by user principal name if you'd like, but account object ID is really ideally the best way to do it if you have it available. So we're going to do a summarize and count the number of distinct alerts. So decount of alert ID based on the account object ID, the account name, and the account domain. To clean things up, we're going to use the project statement to just project out these certain columns, and then we're going to sort it by the number of alerts we have in descending order. And immediately you can see we've got some really funny business going on over here with Barbara Moreland's account. We've got a few more interesting user accounts that are hiding in here, Lola Sunshine, but really 36 plus 17 alerts we've got. So we've got a lot of different alerts associated with Barbara's account. So let's go ahead and dive in and see what these alerts are. So I took the account object ID and I put it up here. And we're going to go for the alert evidence table, where we basically have the account object ID populated for a user-based evidence. We're going to do an inner join on the alert info table. So now we're going to be getting back the alert itself, and we're going to do that on the alert ID. So we're going to count the number of alerts we have and figure out the first and last time that we saw that particular alert type based on its title. So this is kind of a simple little grouping mechanism, and it gives you an idea of time span. And once again, ordering by the number of alerts in descending order. Now, we've got a bunch of interesting stuff here. So we've got a malicious credential theft tool execution was detected. We've got some Tor activity. We also have, this is a malware zap, so post-delivery detection of suspicious attachment. This was something that was delivered to the user's mailbox. It wasn't detected on initial delivery, but then something after the fact triggered MTP and specifically Office ATP to say, we now know this is malicious, so we need to go ahead and remove this from everybody's mailbox. So let's go ahead and figure out when and where this happened. Now, to do this, we're going to use the alert evidence table again, grabbing that user's account ID, and we're going to do a semi-join. So if you remember, a semi-join, specifically a right semi-join, is going to return the rows from the right table when the join key matches. So we're going to join it back together with alert evidence to get all of the evidence. So basically, we're using this as a mechanism to get anything associated with that user account, and then get any evidence associated with an alert associated with that user account. Now, in this case, we're looking for where it happened. So we're going to be looking for devices. So we're going to look for entity type of machine, and we're going to grab the device information itself. As a side note, I did forget to mention, we do have these queries if you want to play along on your own. Again, this will not map perfectly to your specific environment because we are using user and devices that are specific to this lab here. But if you do want a copy of this to analyze on your own, aka.ms/tracking-the-adversary will take you right to our GitHub where you can get a copy of it yourself, along with the other episodes. So going back to the hunt here. So we're going to do a left outer join. So we're going to say, always give me the results from this alert evidence table we have here, and pair it together with the device's information. So we're going to grab the device name and the device ID. And this is basically going to make it a human readable form instead of something that's essentially just going to be this device ID, which we'd have to look up later. Last, we're going to do a count of the distinct alert IDs based on a device name, and we're going to do it on a daily basis. So this bin timestamp 1D is going to say, look at everything from midnight to midnight on every single day and turn it into a time chart. Now, this is kind of interesting. We can see there's a few different devices here. So we've got Barbara MPC, which is presumably based on the naming is probably Barbara's PC. We've got MTP Air AD Connect 01, MTP Air DC 01. So we've got a couple different devices, but we can see, once again, it started on the 18th, and we saw this significant spike between the 18th and the 19th. We have 39 alerts on that one device alone on the 19th, paired together with 2 alerts on the 18th. So let's go ahead and dig into Barbara MPC. So now, to make things a little bit simpler, I've grabbed the device ID. In fact, I'm not sure if I projected it away. Let me take a look. Yeah, I did project it away to make the chart work nicely. But this is the device ID for Barbara MPC. So let's do a little bit of a timeline of the alerts. So taking that alert evidence table again, filtering it where the device ID is her device, doing an inner join on alert info to get the descriptions back. And then we're going to figure out the first time we saw that particular event based on its title on Barbara's PC. So this is kind of a basic alert timelining capability here. So post detection of suspicious attachments. So that's our email zap. We've seen some attachments here from MTP demos going on. We have a malicious file detected by O365. Then we've got Defender AV being turned off. That's a little suspicious. Enumeration of SMB sessions on a domain controller. So there's some really suspicious activity going on here. Some funny PowerShell command lines. So let's start by diving into the malicious detection from Office 365. So using the alert info table, so we can get the actual alert itself, and we'll search by title for this post-delivery detection of suspicious attachment. We're going to do a right semi-join to get the evidence from that particular alert based on the alert ID. And we're going to try and see if we can get the file itself. Now, what we got back, it looks like it's consistently the same SHA-1 and SHA-256, but we've got this great column full of information called additional fields that's in JSON. And I don't know about you, but JSON's a little hard for me to read without parsing it. So what we're going to do is we're going to go ahead and parse out this JSON. So I'll introduce you to a couple of functions here. Once again, grabbing the alert information where the entity type is file, we're going to use a function called parse JSON. So this is going to take a string field that contains JSON information and turn it into what's called a dynamic. Now, we talked a bit about dynamics previously. Basically, what a dynamic is it's an object that you can do dotted notation on, or you can also use this other function I have down here called bag unpack. So once this is in a dynamic format, you can actually just use .name or .directory to pull out these specific fields. But I want all those fields, the name and the directory, as separate columns. So bag unpack will take your dynamic object and it'll take the first level of the JSON and promote it automatically to columns. So this is a heck of a lot easier to read than trying to read it through the JSON itself. Now, I reordered the ones that were most interesting to us here, but you'll see there's also a bunch of information, file hashes, and that's the additional fields itself. So if you wanted to, you could technically actually MV expand out these file hashes and make a 1 row per file hash. But again, we already have the information from the alert evidence table, so it's not really necessary in this case. Now, at this time, we've got updated policy SAO 0718/2020.doc, and this is probably like you can see it came down from the internet, it looks like here. We saw it's in Barbara's iNet cache. So, but let's take a look at this updated policy SAO 0718/2020. Looks pretty fishy. So first question you might ask is, did Barbara or somebody in the environment run something called updated policy SAO 0718/2020? And what we can see is, sure enough, Barbara MPC is shown launching WinWord. with, if you remember, we actually picked it up in the launch string. So if you take a look over here to the right, and sure enough, WinWord, HTTPS, MTP demos, SharePoint com, and that's the actual file name we're looking for. Kind of suspicious. So we can see that she pulled it straight from the SharePoint site. Now from here, we've got a process ID. So let's go ahead and dig a bit more into this process ID here. So to do this, what I'm doing is I'm using a kind of a fancy way of timelining inside of MTP. So I'm using the search operator, and I'm bringing together the device process events table, the device network events table, the file events, registry events, and device events, all together into one view over the last 19 days, where it's that device and that process ID. So this is sort of like a timelining function, if you will. Now I removed this to get rid of a bunch of noise. The rows that correspond to this just aren't that terribly relevant, and I'm ordering it by timestamp in ascending order. And then the last thing is just reordering the columns themselves. And what we can see is that process made active connections to Skype, Office 365, Office Com. Again, these are all Microsoft IP addresses. So from a fish perspective, this is not the kind of command and control I would expect. Then again, we did actually see it go out to SharePoint. So that could be one of these connections as well. So most of these are, in fact, there it is right there. There's a connection to MTP demos, my SharePoint com. Now, after this, we can see we create files. So we have like the local temp file we created for this. We have some additional network communication. We've got, this is going to be, this is one of our internal applications here. This is, I believe this is our Azure Information Protection capability. And last, we've got some interesting memory allocation calls that are going on. So we got device events, NT-allocate virtual memory API call. Now, it's sort of interesting, but we can't really jump to conclusions at the moment. It's entirely possible there's some sort of an exploit in this doc that might be doing some sort of a memory injection. You can also take a look. We've got a protection mask of 64, which I believe off the top of my head is going to be executable and writable memory. So sort of interesting, but again, I don't actually see any persistence coming out of this. In your typical phishing document, you're going to normally see a file write or a registry write that happens in this time frame. That's going to say, okay, we've got a particular, like we wrote an executable file to a directory, and then maybe we attach it to a run key, or maybe we wrote it to the user startup folder, or maybe we just wrote a registry key for the run key that launches PowerShell with a malicious command attached to it. So in this case, it's kind of interesting, but we're going to go ahead and pivot. And since we don't see that persistence call, let's figure out where this thing came from. So if you remember, it's on SharePoint. So SharePoint is in the app file events table. So let's go ahead and search the app file events table for that particular doc name. And sure enough, we've got a file access and we've got a file upload here, which is kind of interesting. But more interesting to me right now is the fact that we've got Azure IPs in the US, and then suddenly IPs that are out of France with this OVH SAS as their ISP. So kind of interesting. Doesn't really mean anything quite yet. But let's go ahead and just dig into these IP addresses. So now, if you remember, the search operator is sort of like a trick I use to search all the tables at once. So in this case, we're going to look over the last 19 days, where we see anything that has either one of these two IP addresses in it, and then just reorder them so it's easier to read. And you'll notice the first things that come up, we've got 3 alert evidences tied to that particular IP address. So we found that string somewhere in it. There's also the app file events, but not really anything else. So let's go ahead and dive into that alert and see what we have. So to do this, once again, we're going to grab the alert evidence, and where the remote IP is in one of those two. I happen to know the IP was in the remote IP column. And do a right semi-join on the alert info table so we can get the actual data back using that alert ID. And sure enough, those are our Tor IP addresses. So for those who may not be familiar, Tor is an anonymization service. So essentially, it's designed to obfuscate where you're actually coming from, and basically bounce you off of either a different part of the world or a different system. So that's kind of suspicious. We'll keep this for later. Again, at this point in time, this is your communication channel. You've got a backdoor, right? So so essentially the doc file itself, if it is a loaded with a persistence mechanism, would be a backdoor. You have a network communication between those IP addresses to the SharePoint site, which implies that we've got some sort of authentication. In fact, let's go ahead and take a quick look at this here. Going back to our app file events, let's take a look from an ABC perspective. So the communication channel is going to be one of these two here. And then we've got BA Morel over here is listed as the account name that did the updates. So that's interesting as well. This implies that this user account was used to authenticate over Tor to upload the document, which is causing all these alerts, which might mean that we have a compromised user account. So this is the account. So once again, account is BA Morel. The communication channel is that IP address, and the backdoor is essentially using a legitimately published service with probably weak authentication if they're able to log in using that user account. So let's go ahead and dig in on the credential theft activity that's been going on. So let's start looking into device logons. So to start off, we're going to take device logon events, which, if you remember, that's going to be whenever we have a logon onto a device that's monitored by Defender ATP. We're going to filter that down to Barbara MPC's logons over the last 19 days where we had a successful logon. Now, you can also take a look into the other types of logons, failed logons and such, but in this case, we're going to be looking for successes just to see what's going on. We'll see what accounts are exposed. I'm going to filter out font, driver, host, and window manager for the moment because those aren't particularly interesting from a credential theft perspective. That you can't really use the font, driver, host from one system to move to the next. And I'm going to rename these so it's a little prettier. So using this extend statement, we're going to concatenate out the domain with a slash. Remember, this is the escape character, so you have to use two of them or use an @ sign, paired with the account name itself. Last, we're going to get a measurement of volume. So we're going to see how many logons we had by account on this is in this case an hourly basis, and we're going to turn this into a time chart. And sure enough, we've got two accounts here. So we've got Barbara Moreland's account, which we would probably expect to be logging onto Barbara MPC. And then we have Eric Gubble's account. And there's a sudden spike of activity right around that time as well. So that's kind of suspicious in and of itself. Why is all of a sudden Eric Gubble's doing a bunch of logons? So let's look into who Eric Gubble's is. Once again, using identity info, this is going to come from Azure Active Directory. So we can see that Eric Gubble's is actually the help desk supervisor. So that's a little concerning. It might imply that Eric is actually has elevated permissions to different systems on the enterprise. So let's go ahead and take a look. So this is again, so going to our ABCs. In this case, we've got another account that's of interest, and it's a potentially administrative account. So this is going to kind of raise that concern threshold up a little bit. So let's figure out where Eric Gubble's has logged on to recently. So if we take a look, we can see since 7/17/2020, using Eric Gubble's account object ID. I stole this one magically in the background to make this correlation a little bit easier. And we're going to go ahead and we're going to look for rows that we have a device name present, and then count the number of times we see Eric Gubble's account logging on by that device name on a daily basis and render it as a time chart. And sure enough, the 18th is suddenly Eric Gubble starts logging on to a bunch of new systems. We see all the Barbara M logons, but we also see the MTP area AAD Connect 01 and Roberto TPC at .mtpdemos.net. So interesting. So these are now suspect systems. These systems we've seen. This may be normal activity if Eric Gubble's is logging on to do PC maintenance. But unfortunately, in this condition, we have to kind of consider them as being potentially suspect, especially since we see that spike up that happened. So let's dig deeper into the account aspect here. So now we see Eric Gubble's logging on to a bunch more locations. Let's go ahead and see what alerts we have. So I'm going to use the let statement to set Eric G alerts to the contents of alert evidence, where we see Eric Gubble's account. And then we're going to do a write semi-join on alert info. So essentially, in this case, we're going to be getting just the alerts themselves back. And then we're going to bring that back again to figure out the alert evidence. So now we're getting all of the evidence associated with any of these alerts. And actually, to be honest with you, this could be slightly simplified by pulling this out here. I had a different plan when I initially wrote this one, but we can actually just simplify this guy here because once again, we don't use that variable again. But now we're getting back all of the evidence associated with an alert that has evidence associated with Eric Gubble's account. Once again, this is our trick for resolving the names for the alert evidence table. We're going to grab the device names and do a left outer join. And then we're going to go ahead and make domain and account be the account domain and the account name concatenated together with a slash. Now, this summarize statement is going to be, we're going to introduce a couple new commands here. So we're using summarize in this case to make JSON sets, which is essentially like sort of like an array, if you will, except a set is going to be unique. You're not going to have multiplicity. You won't have the same entity multiple times. It's like doing a distinct before creating your array. So we're going to go ahead and grab the minimum timestamp, so the earliest time we saw for that associated with that particular alert. We're going to grab a set of devices that are associated, a set of SHA-1s, SHA-2s, remote IPs, remote URLs, and a set of accounts in the event that there's more than one account associated with a particular alert. And once again, ordering it by timestamp. So it's kind of interesting. We can see there's an email from additional malicious sender. I'm not sure what that one is there in this case. We've got Defender AV is being turned off, suspicious LSAS process access. So this is MTP essentially putting together the pieces of the puzzle, if you will, of all the different entities that are involved with things associated with that account. So we've got a few devices, Lola's PC, Barb MPC, Andrew FPC, and that MTP Air AD Connect 01 is associated with a suspected skeleton key attack. Now, this is an authentication attack against a domain controller, where essentially you can, if you have admin to the domain controller, you can create sort of a master key, like master credential, that works for any account. Now, in that case, this is going to be something that requires the attacker to obtain domain admin and use a hack tool, essentially. Now, we've got a few other users in there, a few other devices. We've got a few different SHAs that are of interest. And we've over here to the right, we've got a few remote IPs and different accounts. Now, actually, a real quick note before we go too deep, we're going to go ahead and dig into this IP address here a bit and figure out what it is. But there's also, you notice I used make set if. So now make set if is a special flavor, if you will, of make set. It lets you add something to a set if and only if it matches a specific condition. So in this case, for our devices, we're going to add the device name if and only if the device name is not empty. This gets rid of our nulls, but this is a capability you can use elsewhere if you want to clean up sets, or maybe you want to do there's similar capabilities in count, like countif, for example, where you can specify a Boolean phrase, a Boolean equation that will determine whether or not it's counted or added to the set. Now, let's say you didn't want to deduplicate it. There's also make list and make list if. So make list and make list if is going to add duplicates, even if they add items, even if they're a duplicate that already exists. And there's also make set, which is if you don't want to do the if, you can just do make set and it will just add it without any conditions associated with it. So again, we've got Roberto TPCs in there. We've got a suspicious inbox creation rule. So we scroll over here to the left. You can see we've got a suspicious inbox forwarding rule created, which is kind of interesting in and of itself. We got a potential skeleton key attack. We've got a few logons using potentially stolen credentials, as you can see here. So this is all interesting stuff worth digging into. So first off, though, so we've got that inbox forwarding rule. So let's figure out if we can identify what this IP is. So using the device info table, we're going to look for what the public IP address of the system is, and then get a distinct device name to see if it came from within the enterprise. Now, public IP is essentially the egress IP address that a device would use if it contacted out to the internet. And sure enough, that maps back to our Barbara MPC. So that's kind of interesting in and of itself. So now we've got the Eric Gubble's account creating a suspicious inbox forwarding rule from the Barbara MPC MTP demos net device. So that's something else that we want to queue up for investigation. Now, we had another Word doc that was up there. I apologize. I kind of jumped past it, called BYOD registration doc M. So let's go ahead and dig into the BYOD registration docm. So docm, for those who may not be familiar, is a macro-enabled Word document. We were able to correlate this one. In fact, I'll scroll up and show you where it was. At file events. I believe it's on this one here, if I remember correctly. We're looking at activity associated with that particular, those two particular IP addresses. So a docm file is the new format, if you will, for a Word document file that's macro enabled. You can see right here. This is actually the reason why. I apologize, I jumped over this before. But the reason this is interesting is it came from one of those Tor IP addresses. We see this BYOD registration 1 docm. So this is an example of using a communication channel, the Tor IP addresses, to dig into what else happened around that particular entity, right? And we've also got the BA Morel account, which is the same account we saw uploading this potentially malicious doc file. So that's the reason why that docm file kind of came into question. Apologize, I kind of jumped past that one there, but we'll go back here. So we can take a look and see. So device file events is going to be where do we see that particular file written to a device monitored by Defender ATP. And you can see we've got 8 instances of where that file was written to a device. We've got a SHA-1, SHA-2, and MD5. So if you remember a couple episodes ago during joins, we talked about the file profile capability. Now, one of the cool things you can do with file profile is get that global prevalence number and your organizational prevalence number, which is how many times have we seen that particular file hash in the world. Now, in this case, we've got a Word document, so Word documents can be difficult to trace using hashes because literally any change to the document itself is going to change that hash. That said, we can see if this is maybe a mass attack that was sent out to thousands and thousands and thousands of targets, like maybe an attempt to do like a targeted ransomware attack. This might be a new wave. Now, in this case, we've only seen 4. So 4 is kind of interesting. We can also see we first saw it on April 19th and last saw it on September. It looks like July 10th. Yes. Obviously, it's not executable in this case, but we can get the information all about where we saw this particular file. So in this case, so if you had a piece of legit malware, like let's say you had a backdoor of some sort that you came across, that's a great indicator to determine if it's potentially targeted. If you see a very low count number of instances, but I must warn you, if you see it as not coming back or you see it as perhaps 1, that might be an indication of what's called polymorphism. So polymorphism is essentially an application or file that changes the hash every single time it appears. This is typically done by padding junk, if you will, to the end of the file, or sometimes using there's a bunch of different techniques that they might use to change the hash of the file, but it's a counter forensic technique. There are some more advanced topics such as fuzzy hashes, which can be used to determine those, but that's kind of out of scope for our hunt today in this case. So, but in this case, again, the important note is if you see this global prevalence, thousands or tens of thousands, it's highly likely that this is just a piece of what we call commodity malware, something that's infecting a lot of people. The targeting, if you will, is anybody who they can get to. Whereas if you see a very low number here, say 20, it's either something that's brand new, or it could be something that was customized for your organization, or maybe a small piece of an industry, or it could have just been detected. So these global first and last scenes can come in super handy in that case. So again, a bunch of great information and sort of an example of how to do hunting purely using the advanced hunting interface. So and this is so we kind of covered the ABC concept, talked about how it maps from a hunting perspective. Also, when you're going through your recovery efforts, remember to follow the ABCs again. So you want to make sure you reset admin accounts if necessary, if there's any potential exposure or theft of an admin account. You want to reset your compromised account. So if you know a particular account has been stolen or used by the attacker, or in some cases, you may want to do exposed accounts. So for example, let's say we saw the attacker run a credential theft tool like Mimikatz, and then we saw a user log on, but we don't have any evidence that the attacker stole that account. Remember to keep those as part of your recovery plan. From a backdoors perspective, remember to pivot on your backdoor to see if there's any other locations that have it installed. If it's a publicly facing thing, consider which other entities and user identities and maybe IP addresses have logged on that may be anomalous in nature. And from a communication perspective, if you have a DNS name or an IP address or a communication channel, remember to include severing that communication channel's ability. Now, this can be done through indicators, through Defender ATP. This can also be done with your DNS, your proxy, your firewall. There's all different ways that you can sever that communication channel. But you want to do it in a concerted effort, if at all possible, to make sure you don't tip your hand to the attacker, essentially, and enable them to counter your recovery efforts. But again, advanced hunting doesn't just stop there. And I'm going to transition back over to Tali to talk about a couple other cool capabilities on how we can use advanced hunting and these ABCs to respond to this incident. Tali?
Thanks, Michael. I would like to show you now two features you can use during the investigation if you would like to take actions. We found some very interesting stuff together regarding files, IPs, activities of users on specific devices. And I would like to start with the last file that we found on Barbara's device. We found this malicious file. I will just create again so we can see all the instances of this specific file. We can see all of them are on Barbara PC. And you would like to remediate the involved assets. You would like to quarantine the file. We offer you the functionality to take remediation actions directly from Advanced Hunting. You don't need to go anywhere. You don't need to go to the file page in order to do that. All you need to do is to select the record you would like to take actions on. You need to have remediation permissions to be able to take remediation actions, and then you will have the Take Actions button. Once I'm clicking on it, the wizard of taking actions will get opened. And as you can see, we offer you the option to take actions on devices and files. The different actions will be available based on the result set in your query. To have the device actions, you should have the device ID column. And in order to take actions on files, you should have one of the identifier of the files. And this time we'll go with the SHA-256. Next, you will see all the different entities that will be impacted. At this case, we only have one, which is Barbara PC and the actual device. So the file will be quarantined from Barbara PC. In the target entities, you can see the identifiers of the file and the device. And by default, if there were here more devices and files, all of them will be checked, but you can play with it, check it, uncheck it. And in the next phase, you will have a summary view, and then you can submit the actions. Once you submit the actions will run. And if you would like to see the results of the actions and what happened to the action that you took, you can go to the Action Center and search for the specific entity you remediated or the specific actions you just submitted. So this is one feature that we have. Another main feature that we have in Advanced Hunting is the ability to create custom detections, to create custom policies that will trigger alerts in your organization. Most of the time when you find, for example, specific IOCs as part of the investigation that are identified with a specific attacker activity in your network, you would like to make sure the attacker won't come back. And if they are back in the network, you will get an alert for it. For exact such scenarios, you can use the create detection rule functionality. In this case, I just took the two interesting IPs Michael found during the investigation, and I created a query that will search for any activity associated with those IPs. I would like to focus only on activities with devices, and I would like to make sure to get an alert on it. Next time we see an activity from these IPs, I can create a detection rule for it. Once I'm clicking on creating detection rule, this wizard is opened. At the first phase, we need to enter all the rule information and alert information. So we need to provide a detection name. So we will call it activity involving malicious APs. We need to set the frequency of the rule when it will run every 24, 12, 3, or 1 hour. At the first time we run the rule will look back 30 days. But the next time that the rule is run according to the frequency you choose, the lookback will be different. You can see the description. So for example, if we will decide to go with a frequency of 12 hours, the loopback is the last day, last 24 hours. So we will set it. And then we will provide the alert title. We can choose the severity of the alert, the MITRE attack categories. For some categories, we can also choose the techniques. In this case, I will just go with suspicious activity. We must insert a description of the rule and the alert, and we can also provide recommended actions, what you recommend the analyst to do once the alert is triggered. In the next phase, we will choose the impacted entities. Again, the impacted entities will be available based on your query results. In this case, we have only device and user and no mailbox activity. I will choose that the device is impacted, and I will choose the device ID, which is the strong identifier of the device, and also the user. And I will choose in this case the initiating process account object ID to be the identifier of the user. Once we choose impacted entities, it will impact the incident correlation of the alerts and what will be the impacted assets in the alert that will be triggered. So this is an important state. Next, we can configure actions. The difference between what we did previously with take actions and these actions that previously we took one-time actions on a specific asset we choose. Here, when we are configuring actions, it means those actions will be taken automatically every time an alert is triggered. So it will not be pending to your approval. It will just happen out of the box. Here you see we offer also a user action. We can mark the user as compromised in Azure AD. We are working to offer this function also from the one-time take action functionality. At this time, I will choose to run antivirus scan and initiate investigation on the device once the alerts are triggered. Next, we'll set the scope of the rule. It is based on the Microsoft Defender ATP device groups. And I would like this rule to run on all of them, so I will stay with all devices. And then we have the summary view. We can see all the information of the rule, the alert details we gave, the impacted assets we choose, and also the actions and the scope. Once we are good with it, we are confident with it, we can just create the custom detection rule, and it will run in the backend lookback of last 30 days. Once the rule is created, you can see it was added here under custom detection rule, and we can also find it in this view where we can see all the rules, all the custom rules configured in the organization. Okay, it is coming. So you see that we have here two rules. You can see information about each rule and what was the last run, the status, the frequency, when the next run is scheduled, and so on. If you would like to get more information, this rule is new, so I will use this one. I guess it will contain more information. We can see all the alerts that were triggered following the rule, and if we configured any actions to be taken, we will see a list of actions. In this case, no actions were taken. Of course, you can edit the rule. You can change all the things we just set up together. You can change it in the future. So this is custom detection rules. The last feature I would like to show you is how you can pivot easily into advanced hunting from other experiences in the portal. And one of the main experience we have, of course, is incidents. Many analysts are starting their investigation from an ongoing incident. They are reviewing the different alerts involved and the different assets. And we are giving you a very easily pivot from all the assets involved, whether they are devices, users, or mailbox, into advanced hunting. Once you select an asset, you will have here the Go Hunt button. It will open a new tab to advanced hunting with a pre-populated query about this specific entity. In this case, I chose Eric. So I will get here a query about Eric, so I can get more information about activities that Eric did around the time they joined to this specific incident. So we can see there is the time of, this is the first time Eric was seen as part of the incidents, identifier of Eric, all the different tables we are looking at. And there is also a limit because sometimes it can be many activities. So this is only a base query that you can start hunting for more information on the involved entity, such as more activities. And you can see we have some results. In addition to that, you can also pivot from advanced hunting from the different evidences. From all the evidences, you have the Go Hunt option. Let's see an example of process. Okay, so if we will choose a process, again, we'll have here the Go Hunt, which will pivot us to advanced hunting with the pre-populated query that is relevant for process. And yes, okay, great. So that's it for today. Before we finish our final episode, I would like to invite you to share with us your hunting challenges in the community at akms.mtptc. You can see this conversation that Michael started. We are looking to get your hunting challenges, your questions. So in a future webcast we will host, we will just demonstrate whatever is interesting for you and give you answers for the scenarios you are looking to hunt for. So please come to here and share with us your thoughts.
Thank you so much. So we have a couple of reminders before we are ending the call. I also posted this information in the questions window. So we have some upcoming webinars on Azure Sentinel. It's all about hunting and threat intelligence automation with Risk IQ and Log Forwarder. So have a look. We start August 12th with Azure Sentinel threat hunting and reduced dwell time with Azure Sentinel, and then the week after, threat intelligence automation with Risk IQ, September the 2nd, Log Forwarder deep dive, and September the 9th is optimizing Azure Sentinel KQL query performance. You can find all the details as well as the link for your registration at aka.ms/security webinars. If we missed to answer your questions, or if you have additional questions, you can visit us at Microsoft Threat Forum at aka.ms/mtptc. And with that, thank you, Michael and Tali, for running this awesome Tracking the Adversary series of 4 demo-only episodes. All of them have been recorded, so everyone can go back to aka.ms/security webinars and scroll down to Microsoft Threat Protection and look at them. Thank you all as well for sharing the queries, so everybody can participate and try them on their own demo or live environment. And okay, also thanks, of course, to the rest of the team who helped answer the questions. And most of all, thank you all for being part of our community, for joining us on these webinars. And we hope to see you all next time again. Goodbye.